Okay. Now we are going to look at doing some of this stuff in code. Yeah. So first of all, let's go ahead. We can get some of this real estate back because we don't need it, and then we're going to go over to our code. And actually, let's go back into this. Let's delete these. We don't need them anymore. We're going to be doing this via code. Okay. So rather than having an IB outlet, we're going to look at creating just a labeling code. Okay. Now, because we've done it like this, once again, it's going to give us kind of an issue. But because instead of setting it up with an IB outlet where we're expecting interface builder and UIKit to hook that up for us at a later time, we actually can just create a UI label instance immediately and put it in here and just declare it, and it's all good, right? We're not going to display it or anything yet, but like we're just putting it there, right? So we load it into memory whenever we load into memory, and then we'll hook it up and everything to display later. Awesome. One thing that has changed since I first started doing this, back when I felt that Interface Builder was really the only valid choice. That was because writing UI code programmatically, and then having to hit play and wait 10 seconds to see, and if you're working on a screen that's like a bunch of clicks deep inside of your app, then it's going to take you about 30 seconds to test every pixel change that you make, right? That takes forever, and it's not the way to go. Luckily for us, when Swift added Swift UI, they also added a special macro called preview that you can use. And the preview macro automatically opens this nonsense up over to the right. Now, right now it's giving us an error because it doesn't know what to do with an empty preview, right? So we get this failure, right? But what you can do in here is just return anything that could possibly be anything that can be rendered, right? A view controller, something renderable, okay? Now, if this doesn't show up for you automatically, then what you need to do is click this button here, adjust editor options. Specifically, don't click this button. But this button does a different thing. It creates a new window. It's a whole different thing, right? This button also doesn't work. This creates like a comparison between different things. You want to click this one, this drop down, and then you want to click Canvas. Turn that on. There we go. And once you've done that, then your preview will render over here. This is a live preview. It updates as you're modifying your code, which is really nice. This is something that came with Swift UI, but we can still use it in UIKit, which is also really nice. So let's go ahead and take a look at our header label. And actually, you know what? We don't need this to be a property of our view controller anymore. That's a relic. That's something that was the situation with the IB outlets. If this is just a label that we're never going to modify, we can just do it all inside of view.did_load. We don't need to hold on to a reference to it because it's in our list of subviews. So let's go ahead and create our header label here. So it'll be something like UI label. Okay. We're going to set the text as we saw before, my header label. Okay. We'll set the font. And fonts are semi-complicated in code for Swift. The thing to know is that you can use what's called a system font, which is San Francisco. That's the system font that they use. So it's SF in two different ways. It's San Francisco, and it's also the system font. It's kind of funny. Anyway, so you just hit dot system font, and then of size 36. And that gives us the system font size of 36. Okay, great. But our label isn't rendering. We don't see it anywhere. Why is that? Well, it's because it hasn't been added yet, right? Remember we talked about how every view controller has a view property on it, right? So that means if we do self.view, there it is. It's a UI view, right? We can also refer to it just by typing view, okay? So we do view.add add subview. Wow, it's right there. It's like it knows what I want to do, right? Let's go ahead and add our header label to this. Awesome. All right, cool. Now it'll show, right? Right? Live preview. Where is it? Why didn't it show? Where's my header label? Well, okay, we didn't set constraints. So when you're doing it programmatically, because when you build it with the storyboard, you initialize it from a nib, and it has frame information. It has the X and the Y position and the width and the height that are in the storyboard to start from. And then constraints modify those things if they exist. When we're doing it wholesale from code, it doesn't have any of that information, right? So in order to get there, we're going to have to add some constraints. So we've created our label, and we've added it to the subview, and now we need to do some constraints. The way you do constraints in code, in UIKit, is using NSLayoutConstraint.activate, which is a static method on the NSLayoutConstraint type, and it takes in an array of constraints. You must do this after you add the subview. If you add constraints before you add the subview, you're adding constraints to unrelated views. Constraints can only exist between views that are in the same view hierarchy, okay? So if this header label has not been added yet, and we do things like say, oh, cool, okay, I want my header labels center X anchor, right, to be constrained to the same as my views center X anchor, right? This is the thing that we saw before where the center X, which is that its horizontal position, right, is constrained. So it would be centered in the middle, right? If we tried to set this before they were in the same view hierarchy, it would crash. We would get a crash. So make sure you set your constraints after you add your view to the subviews list, okay? So we've set it horizontally, great, okay. Now let's go ahead and we'll just put it in the center for now, just to be simple, right? So we're gonna match its center, the header label's center Y anchor, right? Its center Y position to the view's center Y anchor, right? Oh, and this is an array, so it needs a comma, okay? Okay, cool. All right, live preview, show me my label, where is it? I'm waiting. It's not gonna show up, right? And the reason for that is because of another kind of legacy piece of UIKit fun. There's a property that you need to set to false. It's this one. It's really long. Translates auto-resizing mask into constraints, okay? This is something that exists for if you create your view using an initializer that gives it a frame, okay, which is a CG rect. So if you say, oh, I want you to be at a specific position with a specific width and height, which is how things were done before auto layout existed, right? We picked specific places for them to go and hoped for the best if it was on an iPad, right? Obviously that didn't work. So they added this thing where all views automatically translate their frame information into constraints when they are loaded and added as a subview, right? However, because we have not set a frame, because there is no frame information, our frame by default is at X position 0, Y position 0, with a width of 0 and a height of 0. Which means that when we add this subview, we are automatically setting a bunch of constraints that keep it at position 0, 0, at size 0, 0. Obviously, we don't want that, so we turn that functionality off. We set translate auto resizing mask into constraints to false, and instantaneously our label renders, okay? When you are setting the constraints via code, you always have to set this to false. If you are the one modifying the constraints on that particular item. If you have a view that you're passing to some container view, like a stack view or a table view or something like that, then you don't need to mess with this. You don't need to mess with its constraints for the most part because its constraints are being handled and managed by its container view. And you don't need to set this translates auto resizing mask into constraints equals false because the container view is already going to be overriding those constraints and placing it somewhere. And so you'll be able to also, there are some constraints you can set, like your width and your height preference and stuff. So yeah, cool. So this is what you need in order to render this here. It's a decent amount of code. This is what we call boilerplate. Basically, a bunch of stuff that you have to do in order to make something work that should sort of probably be automatic, okay? However, it is still the preferred industry way of writing UIKit code because you can actually see what's being done in code, and so you can perform code review on it with pull requests and Git, and you can actually see what the history of the changes of the code is. So it is preferred for UIKit nowadays to do it this way. However, most of the time you will be, if you're using UIKit, you'll be interacting with a legacy system, which may be some hybrid of best practice all in code and a bunch of old stuff in storyboards that no one knows how it works anymore, but it works, so we leave it in, right? You'll find that sort of thing a lot in industry. So, also, this is kind of the motivation for Swift UI. Swift UI is all done purely in code. There is no interface builder for Swift UI. But doing something like this in Swift UI is about like one line of code, right? So, you know, we will be looking at Swift UI after spring break. It's the nice treat that you get to come back to after vacation is a fun new UI framework. It's exciting. Right. Okay, so next up, let's take a look at some buttons. So the main thing that you need to know for buttons is that they have actions, right? You need to be able to tie your action to some code, right? So let's go ahead and create our button. We're going to set the title label. When you set the button's title, you do it with this like set title for, or you can also do it in, I think, is it in here? No, it's not, sorry. Yeah, so you do this set title for state, right? Because buttons have many different states, and if you want your button to change its title based on if the user is pressing it or highlighting it or whatever, you use these different states. But by default, you can just use normal. If you set this as the normal state, this is what the title will be for all the other states unless overridden, right? It's the default, okay? So this is how you set the button's title. And now we're going to, let's see, we've got the text. We need to make sure that we set the translate, auto resize, and constraints equal to false so that we can actually constrain it. We're going to add it to our subviews list like so. Boop. And then we're going to do these constraints again, right? And this time we're going to place this button just underneath our header label. So we're going to say button dot top anchor dot constraint equal to constant. And then we'll say here header label dot bottom anchor. So now we're constraining the top anchor of our button to the bottom anchor of our header label, which is going to put it underneath it. And then we did this overloaded version of the constraint function that gets a constant in, and that can be used to create padding. So we'll put a 20-point constant, and that says, oh, 20 points of distance in between these things. My constraint is of size 20, right? So we do this, we create that, and nothing shows. Why does nothing shows? Bleh, right? Well, buttons are weird. Buttons have this thing about them where they always want to be size 0, 0, always, no matter where they go, no matter how you do them. That's what they want, right? So you have to, and if your button is not being managed by a content container, like a container view, you need to set its width and height. So we're going to go to button dot width anchor dot constraint equal to constant. We'll make this button 100 points wide, and we will make it 50 points tall, like so. And it is not rendered. Oh, gosh. Oh, now I feel like a maroon. What did I miss? Hold on. Title label. Blah, 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 blah. Is enabled. No, that should be fine, etc. And target. Oh, I think it doesn't know where it needs to be in the horizontal realm. So it knows that it's a certain width and height. Cool. Okay, but it can be a certain width and height anywhere. Okay. And it knows that its top anchor needs to be 20 points below the bottom anchor of my header label. Cool. Great. Awesome. But that could be anywhere on an entire plane of existence, right? So it can be the size that we've given on a whole plane of existence. So we need to set its center X to be the same as the view's center X. And now it will render for me. No, it won't. Of course not. I'm sure I'm missing something. Is it that we didn't set the type? Dot system to start with. Oh, there it is. Okay. Apologies, I forgot. For UI buttons, you need to set a type. So here we have our UI button constructor or initializer. We call this type, and then we pass it something from an enum, right? Apple has a bunch of these, right? Don't use rounded rect. It's deprecated, which is sad because I prefer rounded rect buttons, but whatever. But yeah, you can use this system style, right? This is kind of how they like their buttons to be now. They almost look like hyperlinks, right? You'll see that like your edit button stuff, like in the top, it all looks like that, and whatnot, right? So this is our button. Cool. Okay, we've got our button. It's there. Now we want it so that when we press our button, something happens, right? Okay, cool. So how do we do that? Well, I'll tell you. Okay. So first of all, let's create a function, okay? So this function is going to be called change header text, okay? And when this function gets called, we're going to set our headers text to be something else. Now we are like, unfortunately our header label is scoped to view_did_load. I guess we do need this to be a property, right? So we set that. Cool. Okay, header label's still there in the preview. It's all good, right? And here, now we'll say header label dot text equals my changed label, okay? And that'll change the text. So now how do we get it to call this function? One way that you can do it is by creating an IB action. And IB action, basically, if this button was here, right? Like if I'll give a quick example here. If we add this button here, like so, we have this action, right, for the button. Sorry, not that action. Here up on our view controller, we can see now that there is this received actions down here, this change header text. This is the function we defined, the IB action function. You drag and drop it here, and then you can press. We used to always use touch up inside because we didn't have a better option. The better option now is primary action trigger. That's what you'd use, right? So now this button will do that. However, this button is not the button we're using. We created one programmatically, so we're not going to do that, right? Also, I'm so glad they changed that. Used to be that if I had this change header text set to this button, but I deleted the button, then this would still be pointing to a button that doesn't exist, and it would crash if I didn't like-clear it. It cleared itself this time, so great job, Xcode and Apple. You fixed your nonsense from 10 years ago. Good job. But yeah, that you don't have to worry about it anymore. I'm just sharing. I'm passing my trauma on to you, I guess, is what's happening, which is not fair for you. So now, but with this IB action function here, what we can do is we can go to this button and we can do that. Remember we talked about targets and controls, right? How controls can set a target. Well, we can look for target in here. It's like, oh, add target. Okay. And it takes in any type. All right. Well, we'll see, what that'll be. And then the action is a selector. Now, selector is kind of how Objective-C used to handle calling functions. And because UIKit was originally built in Objective-C, this is of type selector. So because you've made this function an IB action, you could also, instead of IB action here, you could do Objective-C, like so. And this gives you Objective-C interoperability by doing this. Both of those are valid definitions for a function that can act as a selector, okay? And the way that you define a selector is with a hashtag, change, I think it's like hash, maybe not. I can't remember. We'll try it. Nope. Yep. Yeah, it's like hashtag, like this and this, something like that. No, I don't remember the syntax for this. Is it hashtag selector? Yeah, it is. Yeah. So you do hashtag selector and then you pass in the name of your function, but don't call the function, just pass in its name, right? And now, oh, okay, this is an action on this target. This target is us, itself, right? And then we'll do this for the event primary action trigger, okay? So now, when we click on this button, and over here, if you, there's two options here, right? One is this one, which lets you kind of, interrogate, your scene. And then there's this one, which lets you interact with your scene. So now we can actually interact and click on this button over here in the preview, right? And our label changed. Huzzah. Yay. It won't change back because that's not how it works. But if we go over here and we hit save, well, if we make a change at all and hit save, then it will have an issue, right? It'll be like, right? And switch back to my header label. Now, what if we wanted to, instead of using IB actions because they're kind of old and stanky, use the new hotness, right? What's the new hotness, okay? Well, the new hotness is actually something that allows us, once again, to pull this header label in and not have it be a property, which is nice because it helps keep our the interface that other people use when interacting with our view controller. It helps it keep it kind of hidden and constrained. Or even when we're interacting with ourself, right? We don't need to change our header label very often, right? Just this one time when someone presses the button, just once, right? In this case. So where do we put this code? Well, you can do, when you create a UI button, there is a constructor that can take in a primary action. And this is what will fire when the primary action for that button occurs. And it's of type UI action, which is a special type that we can construct. So let's go ahead and we'll set our button's type and primary action like so. So we're going to set the type to be system, once again, and then we will set the primary action. The way that you create primary actions is by declaring a UI action like so. And then there's a bunch of constructors and variations of constructors, but the only one that we really care about is the one that only has a handler. So we have this UI action handler. And a UI action handler is a closure. So when we do this, we get this, right? Because if this is the only parameter that we're using in our initializer, then that means that we can use a trailing closure like so. And so we can just call UI action space, open, squiggle brackets, right? Then it has a UI action parameter that gets passed in, and this is the action itself. It's like passing itself to the closure for whatever reason. And now that we're in here, we can change header label.text, right? And header label would go out of scope at the end of this viewDidLoad function. However, because this closure captures it and this closure escapes this function and is held onto as a reference by the UI button, as long as that UI button exists, then this header label is held in memory just so that we can modify it, right? So now that we've done this, we have this action and it's set, and we can click my button and it changes. And now, instead of having a bunch of extra functions added for all of our actions, we can kind of do stuff inline as we're defining our buttons and stuff. Pretty nice. Yeah, so that's UIKit. That's UIKit via code. That's UIKit via interface builder. I also was going to show you one other one, I think, but I don't know if I'm going to get to it here. Stack views. Yes. So let's talk about stack views real quick. Okay, cool. So these two things, they're great. They're awesome, wonderful, right? Let's get rid of them. Not really, but let's take them out of the view, okay? So, yeah. It'll do that every once in a while if it like tries to compile as you're making changes and it crashes. Don't worry about it too much. Just ignore it. All right, let's create a stack view. So stack views automatically handle their subviews, right? Any subviews that are within it, any arranged subviews within it, it automatically positions and places them. Awesome. Okay, so let's create a UI stack view, right? And oh, look, it gets this arranged subviews array. Oh, that's pretty neat. Okay, so we've got this here, and it takes in some subviews. All right, let's look at that later. So for now, let's go ahead and set the background color for our stack view to .red so that we know what we're looking for, and we can see it when it shows up in the screen. Let's set the translate auto resizing blah 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 to false so that we can actually use auto layout constraints for it. And then let's add it to the subviews. So view.add subview, stack view. And then we will also create ns layout constraint dot activate. We're going to create some constraints for it. So we're going to do stack view dot center x anchor dot constraint equal to view dot center x anchor, right? Okay, cool. That's centered that way. And then we'll do the same for the y-axis just to put this back in the center like we had it before. Whoops, wrong autocomplete. Center y anchor like so. Cool. Okay, it's not going to show though because we haven't told it its size. Container views and many views that if they don't have any content set in them for whatever reason, try to be size 0. They try to be as small as they can if you let them get away with it, right? So we're going to go to stack view dot width anchor dot constraint, and then we will just do equal to constant. We'll just set it to the constant 100, and then we'll set the height to constant, and we'll make this one 100 as well because it's more of a square really, and we need a comma because this is an array. And here's our stack view. Okay. Oh, cool. Okay, so let's make it a little bigger. Whoop, sorry, too big. Like so, right? A little wider. Actually, we could go like this, right? Yeah, that looks good. Okay, so this is its width and height and stuff, right? This is our stack view. It's cool. It's dope. It's a stack view. So now let's go ahead and say, okay, so we can get rid of this translate auto resizing because we're not doing constraints anymore on these two, right? And let's add them as arranged subviews into our stack view. Like so, right? Okay, that's interesting though. They're in line, right? Why is that? Well, it's because stack views default to being horizontal for some reason, even though phones are, typically, not horizontal. That's what stack views default to. So you need to set the axis to vertical. Oh, cool. Okay, look at that. That looks very similar to what we're used to, isn't it? Right? So now there is a lot of extra spacing though. What's that about? It's because stack views have a bunch of different ways that they handle extra spacing if they have a particularly set size. But because we have these contents now, we don't need to set a constraint for the size of this stack view. It will render just fine without it. It can interpret what its size should be based on the internal content requirements, right? So, okay, now we only have these constraints and we get basically the same result except for this red nonsense, but we can just turn that off and now you can't see the stack view at all. Nice. And if we wanted to have that 20 points of space in between once again, we can set spacing to 20. And spacing is a property on stack views, right? Okay, cool, great. And this is really nice. Stack views are a much nicer way to lay out your view than constraints are, but you will still need to use constraints to handle your stack views, usually. You can put stack views inside of stack views inside of stack views and kind of just chain them forever, and that works out really well too. And then the last thing I'll show you is that if here, instead of changing the text, we change the is hidden value and we call toggle on it, which changes it from if it's false, it turns it true, and if it's true, it turns it false, right? That's something that all Booleans can do. You can call toggle on them. If we do this and we hit my button, then you can see it does a cool like fade out kind of animation and my button's position gets moved. And that's because stack view is adjusting for the fact that something inside of it is hidden. When you have container views, they typically are able to handle their arranged subviews being hidden or made not visible. And when that happens, they adjust the position of all the other views within them. This is how you can have things that fold out and fold in and all sorts of stuff like that. So that is stack views, that is buttons, that is labels, that is constraints, that is UIKit and view controllers in code. Any questions? With 1 minute left to spare. Kind of squeaked in here today. Cool. All right, let me talk to you briefly about your assignment tonight. Wrong one. Excuse me. Oh, is it? Hold on. Let's go to Canvas. I have to log in and everything. Oh no. This is what happens when I close something. I'm gonna have to use the Duo login thing. Oh no, it remembered my session. Oh, thank goodness. I don't want to keep you too long. Okay, so we go to assignments, class 7 assignment and reading. All right, so this assignment is to build an iOS app that uses the SPM library you created in the class 6 assignment as a local dependency. Oh gosh, I didn't talk about local dependencies. Okay, we'll do that real fast. Super simple. You go to File, you go to Add Package Dependencies. Okay, you click Add Local, and then you navigate to where your dependency is, right? In this case, whoop, it's just being slow. It's over here. It's this let's count lib, right? You click Add Package, Add Package. Now you can import let's count lib in your code. So you can say import let's count lib, and it'll autocomplete. And now we have access to the counter API session that we created. Cool. Okay. Super simple. Right. All right. So you're going to use that library, and instead of having a like a text, a command line interface for interacting with the service endpoint like you did, the service API like you did last time, now you're going to create this. This is what you're building today. Not today, but this week. This week is this is what you're building. And this will, you basically put your namespace and your key in, you click start, that'll start your session. If your session is successfully started and it exists and everything, then this will be turned into, this will print out the namespace /key, right? For now, for this assignment, you don't have to worry about creating namespace and keys that don't exist. Just use the ones that you created in the previous assignment on the command line tool, okay? Just, use existing ones that you've already made. If you didn't make any using the command line tool, you should probably go do that and finish that one and then do this one, because these assignments are going to start building on each other now. Now that we have all the basics, they're going to, we're going to make a really nice counting app through the assignments, which will also teach you kind of how to make a really nice app for other API services or service APIs, which is literally your final assignment. So, okay, I kept you 2 minutes over. I am sorry for that. Yes. Any questions before I stop recording? All right, you're free. Go. Enjoy your weekends. Have fun.